So we're talking absolute value equations. If you think about the absolute value of x being equal to 4, think about the numbers that have absolute values of 4. Either positive 4 or negative 4 would both have absolute values of 4. So that's because, you can probably hear my cat meowing, that's because numbers that are 4 units away from 0 are what we should be thinking about when we think about the absolute value of 4, and those numbers are 4 and negative 4. That's because the absolute value of a number is the distance from 0 to that number on a number line, or the distance between x and b is the absolute value of x minus b. That's because if you think about how you find the distance between two numbers, you subtract them to see how far apart they are. So if I'm looking at this absolute value equation, it says that the absolute value of x minus 4 equals 2. That means that we're talking about the distance between x and 4 being exactly 2 units. You could draw a number line and go, okay, well I know that the distance between 4 and my mystery number x is 2 units. So if I go 2 units bigger, because direction doesn't matter, or 2 units smaller, then those two numbers are 2 units away from 4. So x could equal 2 or x could equal 6. Now the thing that is sometimes a little bit confusing is you do subtract numbers to figure out how far apart they are. Like between 100 and 6, you subtract 100 minus 6 and get 94. So if it's written in terms of addition, you're going to want to rewrite it in terms of subtraction, but still have it equal to the original. So like x plus 4, the absolute value of that is the same thing as the absolute value of x minus negative 4. So if I'm solving this one, this x plus 4 absolute value being equal to 2 really says the distance between negative 4 and x is equal to 2 units. So that would give you x equals negative 6 or negative 2. Rewriting your addition as minus a negative is a good place to start with on those. So this is an addition one, like we just talked about. I'm going to rewrite it as 2x minus negative 4's absolute value being equal to 6, which if you write a distance statement, that means the distance between negative 4 and 2x, or between 2x and negative 4, is going to be equal to 6 units. So it's a little bit different because it's 2x instead of just x, so let's see how that works. So I'm going to draw a number line, and then I'm going to put my negative 4 that I have in the middle. Now I know to get to 2x, I'm going a distance of 6 units, either bigger or smaller than negative 4, which would put me at 2 or negative 10. Now that gets me to 2x instead of x itself. So I know that 2x is equal to negative 10, or 2x is equal to 2. So there's basically one extra step here. So to solve for x, divide by 2, and you get x equals negative 5 or positive 1. So there's some situations where it's not convenient to solve using a number line. So you could write two different versions of your original equation, solve them, and then make sure to check in your original. Say you have like a quadratic. X squared plus x, the absolute value of that's equal to 6. Well, you know that the inside, whatever x squared plus x is either 6 or negative 6, because those are the only two values that would get you an absolute value of 6. So you could write x squared plus x equals 6, or x squared plus x equals negative 6, and solve them individually. I prefer the number line, and especially when we're doing inequalities tomorrow, you'll have to be able to use the number line, but this is an option for some equations that are more complicated. Like on this one, I'd start by getting my absolute value part by itself, and then dividing both sides by 2 to make that happen. I can't multiply my 2 in, remember, because it's a absolute value, not parentheses. Distributive property doesn't apply. Then I get to the point where I have the absolute value of 4x plus 3 equals negative 2. Well, if you think about what this says in terms of distance, this says the distance between 4x and negative 3, since it'd be minus negative 3, is equal to negative 2. But you can't have a distance be equal to a negative number. So this actually has no solution. Instead of writing my two cases and solving, wasting all that time, I'm going to notice that right now and just stop. If you look at part B, that's one where making our two cases is going to be necessary since there's an absolute value on both sides of my equation. So I would either have 4x minus 3 be equal to x plus 6, or I could have 4x minus 3 be equal to negative quantity x plus 6. Essentially, your two values inside could have the same sign and have their absolute values be equal, or they could have opposite signs and have their absolute values be equal. Say, think about a number like absolute value of 9 would equal the absolute value of 9, or absolute value of 9 would equal absolute value of negative 9. You could put that negative on the other side and have like negative times 4x minus 3 instead of negative on the right side with x plus 6. If you solve each of those individually, you're going to get x equals 3, and then distributing my negative and solving my other one, you're going to end up with 4x equals negative x minus 3, which gives you 5x equals negative 3, and x equals negative 3 over 5. We do need to check both of those, so plugging them back into the original one at a time, I'm going to first do 3. Make sure you do plug it back into the original with the absolute value symbols. So that'll give you 4 times 3 is 12 minus 3 inside your absolute value. And that'll be absolute value of 9. Want to know if that's equal to absolute value of 9? Yes, it is. So 3 works. If you do your negative 3/5, plugging it in, then on the left-hand side, we're going to have that. Right-hand side, little fraction work in your calculator or common denominator. You're going to end up with, I think, let's see, that'd be 27 over 5. On the left-hand side, absolute value of negative 27 over 5 is positive 27 over 5. Those are equal to each other. If you think about an absolute value equation being equal to 0, this is kind of like a special case here. You could make your two different equations, but like if you go, oh, that's equal to 0, or the opposite sign of 0 is still 0. So you're just going to come up with a single equation, or single solution, sorry, x equals negative 2/3, that you can plug back in and check. And then you'll get that that is 2 minus 2, and the absolute value of 0 is indeed 0. If you think about what this means in terms of distance, I always want to relate things back to my idea of absolute value being a measure of distance. Then our equation said the distance from negative 3x to 2 is equal to 0 units. So basically on my number line, I'm starting at 2, and to get to negative 3x, I'm going nowhere. So I'm just going to have whatever x value makes negative 3x be equal to 2.